Hello everyone, welcome back to the another session in Principles of Programming Languages. We'll continue to learn about the fourth unit. The next topic of fourth unit is design issues of data abstraction. So generally we'll keep some points as to be maintained by all the languages as part of design issues. Now, so let's see about the fundamental design issues of data abstraction. So there are three design issues what to be maintained in the languages. The first design issue is what? Abstract data types is the form of a container for the interface to the type. We'll see in detail as we were going to talk about how data abstraction is being provided in every language. And the second design issue is whether the abstract data types are parameterized or non-parameterized. In the earlier video, in the previous video, we were discussed about process abstraction, right? There we were seen about one thing related to stack. Now let's say stack is my function or stack is my process, stack is my subprogram, what I wanted to do in the program. Now, if I am talking about this stack, it can have some parameters inside of it as part of the operation, or it may not have any parameters. Now the point is what? We will learn with the subprograms, whatever things you are passing here, that is a parameter, right? Even in the abstract data type, as abstraction is even provided for the process or for the subprogram or for the data, we will be keen concentrate on this parameter, whether the abstract data types really parameterized or not. If it is parameterized, how the languages will take that into implementation part. That also we'll see. Next is about, so there is an example, if the language supports parameterized abstract data type, one could design an abstract data type for some structure that could store elements of any type. The third design issue is when we are using the abstract program or subprogram in the program. Let's say that I wanted to write one abstract data type, something that I'm taking off add with no parameter. Now this is my data abstraction. When I can say it is an abstraction? So when it is follows these three design issues. If it is a container to perform some task, and if it is having some design issue which is of parameterized or not, though it is having these two design issues, there is the other design issue which has to be maintained for sure in the data abstraction, which is information hiding. That's what will be giving some access control. Wherever you provide these three design issues, hence that is belongs to data abstraction. If you don't have this third design issue, we'll say it is as normal as it is a subprogram. Because we learned about the subprograms that it is a container where we'll interface the instructions to be in the program and we'll write some parameters into it. Now where is the difference in between subprogram and data abstraction? Yes, the difference is what? We'll write the subprogram in the program, and whatever subprogram you are writing here, if you don't maintain this third design issue which is information hiding, if you don't have that characteristic in the program, you cannot say that abstraction is provided. When this process is providing abstraction, when it is fulfilling the third design issue also. What is third design issue? Information hiding. That is what? Giving access control to the particular user. Right? That's what the third design issue is. What? Access controls are provided and how such controls are specified. It is most and most important. If you don't mention this third design issue, it is as simple as your subprogram. So we should show the justification for data abstraction that will be shown with the help of access control. And so finally, the language designer must decide whether the specification of the type is physically separate from its implementation, or you are really writing the subprogram in the another part of the implementation. So these are what the fundamental design issues of data abstraction. Now we'll see about the languages which will support data abstraction. So we know about this that C doesn't have data abstraction types. The reason is what? We don't have that, we cannot hide the data with the access specifier. As far as structures will show you the best example of data abstraction, concern to the C programming language. Even COBOL also will use data abstraction concern to the records. Though we have a feature of data abstraction inside of it, we cannot have access specifiers to hide the data from the user. So that's the reason why we are not including those languages into the picture. But there are the languages purely which will support data abstraction, and those languages are what? Those languages are ADA, C++, Objective-C, Java, C# and Ruby. These are what the programming languages which support data abstraction. Now, we'll be going to see about each programming language, how implementation part of abstraction will be handled in the language. Because from the starting of 4th unit, we were discussing about 2 parts, correct? The part is what? We will be writing some process, and this process will be declared in the program, will be defined in the program, and will be called in the program for many times, as many times you wanted to execute the same process. Now, when you wanted to execute the same process, for sure we'll write representation part or specification part, and also we'll write implementation part. These 2 things basically we'll write, and that's what we say it is function declaration, and that's what we'll say it is definition, which is implementation as equal. Now the point is what? We have to hide the data where it is involved in the implementation part, because implementation part will have a major influence in the function calling statement. Let's say that function calling statement is calling for addition of 2 numbers function. Now implementation has been changed by some other person, because as far as we don't have any access control specification, if it is modified by some other, then what will happen? Your function will not be, though function is calling of addition, but the task has changed, result will get influenced, right? So that's what we will be very conscious while we are declaring it, while we are defining it, and while we are calling the subprogram. That's what will maintain implementation part is hidden from the users. Now you may ask a question. If you are hiding the implementation part, if I am the right person who wanted to change my code, then how can I do it? Yes, that's what, we don't have one common access control. We do have 5 kinds of access control specifiers. As part of the previous study, you may be aware of, I'll clear this and I'll write. You may be aware of this. Public, you may be known, private and protected. You may be known about these 3. But concerned to major programming languages, access specifiers are 5, which are the same: public, private, protected. Now, the 4th one is limited private. 5th one is limited protected. These are also added to the list of access controls or access specifiers. The job of these 5 are, will hide the implementation part from the user. If you are giving an access specifier as public, now it will be hidden to 0 user, because we specified it as public, everybody can see it. If you wanted to restrict the access of the others, we'll write the private. If you wanted to protect it, that you don't want it to give anybody else other than the developer of that code, then we'll make it as protected. If you wanted to make it is for limited number of inputs, let's say that I wanted to hide the data for only 1 to 100 input numbers, we'll do this limited private and limited protected. So this limited is a thing, will limit the inputs. When the inputs will get changed, the access specifier will be given access. That we'll see in detail when it comes to the language picture. So as I told you that we'll be going to talk about all these languages in detail. and at the time of each language, we'll discuss about how the implementation part of access specifiers will get handled. Now, we'll see about abstract data types in ADA programming language. Now, so basically, as I specified earlier, ADA is a programming language which supports data abstraction. How it supports data abstraction, that we'll see. So, ADA provides an encapsulation. ADA supports an encapsulation, and ADA supports an information hiding. Both the things are supported in ADA programming language. Encapsulation construct that can be used in a defined single abstract data type, including the ability to hide its representation. Right? Now, ADA IT3 was one of the first languages offer full support for abstract data types. That means the three design issues what were maintained or what were discussed, that all are supported in ADA. Now, that will supports with the help of encapsulation and information hiding. Let us talk about these two factors in detail. The encapsulating constructions in ADA are maintained in terms of packages. We'll write package. So, generally encapsulation is what? We'll wrap the classes what we needed in the program. Let's say that you need 2 or 3 different classes are to be needed for your program. We'll wrap all the things into one package. So, that wrapping of data is called as encapsulation, and here encapsulation is what? We will maintain in ADA language through package. And a package can have 2 parts, which is also called as, a package can have 2 parts, each of which is also called as a package. And those are what? Specification package, and the other one is body package. That's what we were discussed in the common phenomena, that we'll be having representation part or specification part and implementation part. Now, the words are particular from language to language. Representation specification part is called as specification part, implementation part is called as body package. So, data abstraction is maintained in ADA programming language by restricting the access of body package, which is implementation part. Now, so let's see how it is maintained. With an example, we'll see now. A package specification and its associated body packages share the same name. That's true, right? Now, we'll see with an example. Now, so look at this example. So, in this example, you will find something new, which is this will be having 2 parts. As I specified in the previous slide, this program you can see in 2 parts. One part is what? Specification part. The other part is body package, a body part. Now, as far as this is considered, now look at this. Package stack package. Now, I'll take this. The following is the package specification, package stack package. So, this is what it says about. This is what it says about specification package. If it is a body package, we'll use a word of body package, right? Now, so it is specification, specification will be visible. So, the visible entities are public interface type. For stack type is what? Limited private. See, look at this. And I have to mention this point very clearly. ADA is the only language, okay, which supports 5 access specifiers. All 5 what I have discussed just before, all 5 access specifiers are being supported in only ADA language. And you will not see all 5 in other languages. Let's see, limited private, maximum size constant is equal to 100. Now, it is limited to access only 100. Other than this, we cannot go. The visibility will not be there if you cross this figure of 100. Now, function empty, procedure push and procedure pop. So, these are all what? These are all what? The public things what are shown to the user. Now, there are things which are private. We say it is private data, and the data which is consisting inside, we say it is private type of data. So, this private type is not visible to all the persons. Fine. Now, so this is what your specification part. Now, let's see the body package of this ADA. Now, this is what your body package, and this will be hidden. Fine. Thank you all.